Hello, this is Lady Tahila from the Covenant of the Open Mind, Elder of the Open-Minded Path, and you're watching Metaphysics 101. Hail and welcome. The topic this time is the Standard Model, which is an aspect of physics that describes the nature of particles and the forces that govern these particles and how they all interact and relate to each other and how they're all derived from fundamental principles. We're not going to get too into detail about how they're derived. It's a lot of math. I'm just going to kind of summarize the math in a more intuitive way, just describe why the parts of the math that are relevant here. And really, it just comes down to something called spontaneous symmetry breaks. So when you go to derive these forces mathematically, at some point you start to see where they break apart. The spontaneous symmetry breaks are really just a mathematical phenomenon that results in different carrier particles with different properties, but each with a similar function in determining how the forces behave and interact. And that's why it's called the Standard Model, because it's a model of physics that shows the forces in a similar way across the board. The carrier particles are the bits of energy, really, that facilitate interactions between other bits of energy. So you'll remember back to the first lecture, we talked about photons. We talked about the behavior of light. Photons, are the carrier particle for the force called electromagnetism. What a photon really is, it's a wave. If you remember back to the previous lectures, we talked about the nature of particles to be both waves and particles, to be both little dots in space, like little point specks, but also waves that exist over all of space, ripples, if you will. Photons are the ripples specifically of the electromagnetic force. So whenever we're talking about electromagnetism or electromagnetic radiation or the electromagnetic spectrum, what we're really talking about is light. Electromagnetism is a field that goes across all of space and all of time that describes the way in which charged particles and magnetic fields interact with each other. And at first glance, electricity and magnetism look like very different things. But when you put a moving charge through space, you'll get a magnetic field. And so a photon is really just oscillations of two different kinds of fields that exist perpendicular to each other as it goes through space. Changing electric fields, right, moving charged particles creates magnetic fields, and changing magnetic fields creates electrical charge. They're intimately related, which is why we call the force electromagnetism. It was first believed that you had electricity and magnetism, and then some really smart people came along and found out that those two forces can be unified into one force, and in fact need to be unified in order to truly understand the nature of light. Some important things to note about electromagnetism, which we've talked about in detail in previous lectures, but we haven't yet called electromagnetism as a force. The important features to note are it's incredibly strong when compared to gravity, right? So when you have two massive objects in space, like we said in previous lectures, they attract each other. Electrons are massive objects in space, so they should attract each other, right? But they don't. They repel each other because they have opposite charge. Opposite charged particles will push apart harder than they will pull together. This is incredibly important because electromagnetism is the force that holds things together and keeps things from falling into each other. The reason why you don't fall through the floor towards the center of the earth is because the electrons on the outside of the atoms within your body repel from the electrons that are outside of the surface of the floor. And if gravity were stronger than electricity and magnetism, you would fly through the floor towards the earth. But you don't. The floor is solid and sturdy beneath you because of electromagnetism. So gravity is the weakest force, and electromagnetism is the next strongest force. And it's stronger by a very large factor, by like 10 to the 40 times, like huge factor. The next strongest force to talk about after the electromagnetic force is the weak force. And we've sort of talked about it in previous lectures, but not really in any detail, and we've never named it before. The weak force is the one that governs particle decay and that allows for one particle to turn into another particle. And what we're going to find as we keep talking about the science here is that particles, they're really just energy, right? As we've discussed extensively now, E equals mc squared. And so, you know, one kind of energy and another kind of energy are sort of the same thing. And that's why you can turn one kind of energy into another kind of energy, right? Because it's all just energy. The weak force is what governs how a particle gets turned into another particle. So if you have a neutron and the neutron decays, poof, then you get an electron, a proton, and you would expect those to kind of attract each other, or because of the force of the decay, maybe fly off in directly opposite directions, but they don't. What we find is that they kind of fly off, you know, in an angle to each other. And the reason for that is because there's a third particle there, a very, very small particle that's very similar to the electron called the neutrino. It's similar to the electron, but it's completely different at the same time. It's practically massless, it's really, really small, and it doesn't have a charge, so it doesn't interact gravitationally or electromagnetically. This is why there's like tons and tons of neutrinos constantly flying through the Earth, through the atmosphere, through your body. It just does not care at all about the fact that you are a macroscopic massive object that's held together by electromagnetism. It doesn't matter that you're attracted to the Earth because of gravity. It doesn't care at all about those two forces because the weak force is much stronger. The mediator particles, like we've talked about for electromagnetism, there's a mediator particle called a photon. When you shoot a photon at an electron, you know, that's how two electrons interact with each other. That's how they know, hey, I'm heading towards you. Oh, okay, we better move apart now, because they send a photon between them. That photon can travel very quickly and across vast distances because it's massless. There's nothing to slow it down. There's nothing to attract it to one thing or another. It just keeps on moving until it hits another electron. The carrier particles for the weak force are called bosons. There's 3 of them. And the reason why they have mass, again, comes back to that spontaneous symmetry breaking. So all of the forces have this sort of symmetry that at high temperatures and high speeds, all of their carrier particles and all of the forces kind of behave in a similar way. But the minute that everything starts to cool down or get farther apart, you know, after the universe went from being super small to booming out to a much larger space and started cooling off, that's when you start to see the forces behave differently and their carrier particles behave differently. So the weak force only interacts over very small distances because the carrier particles have mass, which means they can't move very far before they get redirected by all the other forces that exist in space. The last force we haven't discussed yet is aptly named the strong force. And we haven't really discussed this at all yet. The strong force is what keeps atoms, the nucleus of atoms together, because the nucleus of atoms, for those who know, is full of neutrons and protons. Neutrons are electrically neutral, so they have no problem sitting close to each other, but protons are all positively charged particles. So they should, according to electricity and magnetism, repel each other. They don't. They stay stuck together inside of the nucleus of an atom. Why? Well, that's because the strong force is stronger than the electromagnetic force. The force that keeps those protons together, that keeps the particles that make up those protons together, because protons are actually made up of smaller particles called quarks. And the flavor, or the way that the quarks interact with each other in the strong force, is actually called color. It's not really a color at all, because remember, color is a function of electromagnetism, right? It's a function of light. So they're not really colored, because we're not talking about electromagnetic interactions. We're talking about a different kind of interaction, and they're just called color because why not, right? So we have charge, spin, and color. Different properties of particles that determine how they interact according to the different forces of nature. Now, unlike the other carrier particles, the carrier particle for the strong force, the gluon, does interact under the strong force. So, you know, photons are electrically neutral, so they don't interact with the electromagnetic force. They are the carrier particle of the electromagnetic force. The bosons, they have mass, so they move over small distances only, but they don't really decay at all. They're not governed by the force that they carry. On the other hand, gluons are governed by the force that they carry. They can interact with the strong force, and that's what keeps them confined to the nucleus of an atom. You'll never find a gluon outside of the nucleus somewhere. The gluon will always be stuck inside where all the quarks are. Not only do the gluons carry the strong force, they also feel the strong force. Now, you may ask yourself, what causes the spontaneous symmetry breaks? What force in nature exists that causes these particles to behave differently in different contexts if they're really fundamentally all the same force? And that would be what's called the Higgs field. It's what creates the property of matter that allows for gravity to exist. It's kind of like if everything in the universe were just in a big pool of molasses or Jello or something. And as things move through that field, how much resistance they experience as a result of that field determines how much mass they have. It's not a perfect analogy. It's not like something is going to eventually slow down like it would if it was moving through molasses. The Higgs particle, the Higgs field, is believed to be what gives things mass. So that's a lot of information for you about the Standard Model in general, what particles are governed by which forces and what the different particles represent. Now I want to talk a little bit about what it means that all of these forces are really one force, going back to that idea that the universe is one. These forces were all one at one point in history, very early on in the early universe, when the universe was still kind of a hot, soupy plasma mess. And if you look at the math, which we're not going to get into because it's very complicated, you find that under certain circumstances, they all behave the same way. And when temperature is lower, when things get farther apart, when things are moving more slowly, that's when you start to see the differences in the forces. So that's why it's called the theory of everything, because they're all really one thing. And then you have these spontaneous symmetry breaks that cause them to appear differently and to function differently on macroscopic scales, on the scales of the astral realm and the quantum realm, etc. So when you get into these higher forms of science, quantum field theory and quantum gravity, which we're going to head into in the next few lectures, you start to look at everything only in terms of energy, and you no longer care about which one is the width and which one is the depth and which one is time. They're all really the same. All these dimensions are really, they function the same way, except time gets a negative sign in front of it. But otherwise, they're all basically the same thing, and you can just treat everything in terms of energy. So through the union of these forces, through the Standard Model, what we find is that the barriers between all of the physical things that seem separate to our eyes, in our experiences, are really one thing, are really unified, and the universe really is one interconnected process. Height, width, depth, and time are really just properties of energy that determine how that energy functions, what it looks like, how it behaves once that energy starts to behave like matter. So a lot of this lecture has just been setting us up for the content of future lectures, but I do still want to bring it to a metaphysical point and find some kind of underlying wisdom in the Standard Model that correlates with spirituality and with belief. And the correlation between the Standard Model and spirituality is actually from a primitive understanding of the fundamental forces of nature, which really shows the power of intuition, the power of a person who learns enough of the way the universe works, who cares enough about understanding the physical nature of the universe to be able to find truth in intuitive understanding. So let's just start from the weakest force and go to the strongest force and talk about how each of these fundamental forces of physics ties into an element or an understanding of how things behave. So the weakest force is gravity. Gravity has a sort of flow to it. There's no push involved. There's just this very natural sort of pulling of things together. Gravity describes the nature of objects to pull, to receive, to come together. It describes attraction. So that's why we associate it with love. So gravity really is captured by water as an element. Water is the force of nature that is pulling things together. And that force in physics is called gravity. The next strongest force is electromagnetism. As we said, electromagnetism aligns with Earth because it keeps things together. Electromagnetism is the basis of structure, of form. Electromagnetism is the force that keeps particles together and forms physical structure and physical objects like the table, the floor, your body. And this is exactly what we say in Wicca and witchcraft. We say that the earth is physical form. And that's what electromagnetism gives us. It gives us matter, it gives us macroscopic objects. And that relates to the element earth. Earth is the intuitive way of understanding this force that gives form and structure. The next strongest force is the weak force. The weak force is what governs the engine behind stars. Stars provide all of the light, all of the push out into the universe, all of the energy that we use to function. So energy comes from the weak force. It comes from fire. It's what provides us with decay, fission, or with conversion, fusion. And that is the generation of all of the energy that brings all life to the universe, that gives push into the universe. The weak force aligns with energy, it aligns with generation, it aligns with sunlight, it aligns with giving energy and animation to the universe. And that's why we associate that with fire. It's a primitive way of understanding the force that is push. Note that fire is also known to be destructive. So is the weak force, right? Nuclear decay, nuclear bombs. All of these things are massive sources of destruction, and all of them are caused by the tiny little interactions that occur when particles decay or are shoved together and form larger particles. Now, the strong force, the strongest of the forces, is the most mysterious. The strong force keeps particles that should in every way repel each other together beyond all sense of reason. This is the first force. This is the one that breaks down into the other forces as things cool off and get farther apart and move more slowly. So the strong force is really the first level of discreteness in the world. It's the first step away from a soupy, chaotic, but somehow ordered mess of things into a world where you have macroscopic objects, where you have matter, where you eventually have life. So the strong force aligns with air because it represents mysticism. It represents making order from chaos in a way that defies reason. So as you can see, the elements are really a way of classifying how things behave according to the fundamental ways that things can behave in the universe. And when you start to study the physics, you start to realize that this really is how things function on a fundamental level. These are the 4 ways that things can behave, that energy can behave, that energy can interact and form matter. And without all 4 of these different types of interactions, nothing exists the way that we know it. So obviously what I'm not saying here is that if we align certain herbs with water, that they have stronger gravity than other herbs. Okay, that's nuts. Everything that exists behaves in some capacity according to all 4 of these forces. And that's just another intuitive way of saying everything contains everything else, right? And that's another thing that we say in Wicca and witchcraft, that all of these elements are really all of them present in everything. And one person can be like, well, I'm best aligned with water, I'm best aligned with air. But every person contains all of the elements in some capacity. And when you have all of the elements together, when you unify all of the elements, what do you get? You get spirit, you get transcendence, you get pure order, okay? You get what you see in the very early universe before all of the forces separate and become different things. The universe is one thing, one energy, one continuous force. The only thing that makes us distinctly separate is the fact that the sameness of these forces is concealed from us due to the discreteness, due to the separation, the spontaneous symmetry breaks that allow these forces to function in different ways. So I hope everything that we said here today makes sense. If you have any questions, please drop a comment, join our Discord server. You can find the link at openmindedpath.com. And I really hope you guys are starting to appreciate that whether you start from a scientific place or an intuitive place, as long as you're leaving delusion behind, as long as you're really looking at things through the right lens, you can come to the same conclusions. And that's really the whole purpose of this lecture series, to demonstrate that science and religion are not dichotomous. They're not opposites. They're just different ways of understanding the same universe. And having an intuitive understanding of the universe and having a scientific understanding of the universe are both important. This lecture is building towards something really, really cool. So I'm going to go ahead and cut us off here so we can move on to future lectures and get really, really deep into the metaphysics and learn some really cool things. From everyone here at the Covenant of the Open Mind, blessed be.